All right, guys, let's jump in. Let's talk about substitution a little bit more today. Random fact: the combined weight of all ants on Earth weighs almost as much as the combined weight of all humans. That is disgusting. We're not talking about numbers of ants, we're talking about weight, which means for you, there must be 130 pounds worth of ants out there. And for me, there's another 160 pounds of ants out there running around for almost every person on Earth. That's just gross. All right, let's dive in. So we talked about substitution yesterday, and in those substitution problems, we always ended up with something, or started with something like this, where you had the equation solved for y, or you might have it solved for x, and you could immediately plug in. We would just take that 2x, and we would substitute or replace that into the other equation for the y. But what if they're in standard form? Here we can see there is no y or x that the equation equals, so we can't really use substitution to start. And of course, you've already got the skill. Hopefully you already know what I'm going to tell you. We just need to rewrite our equation to solve them for x or y. So notice you have the choice at this point. You can solve for x or y. Either way, you'll have an equation you can plug into your other equation to solve. So for instance, if I look at this system, these two green equations here, I could decide I want to solve for that y right there. And if I do that, I would just add my 3x, bring it over to the other side. And now I'll divide off that -7. But there's one thing I don't like about this. 21 divided by -7, -3. And the 3/7 with the 1 negative is going to stay like this. This is what I'm not a big fan of. I've got a fractional value. Now that, if I'm going to graph this, that's great. Excuse me, guys. Because that's my slope. I'm now in slope-intercept form now that it's solved for y, and that would be easy to graph. But if I wanted to use substitution to solve, I would have to take this and replace that in the other equation for y. So now I'd have -3 minus 3/7 x plus 2x equals 9. And I could do that. This is all mathematically valid. But now I've got to deal with this fractional x in the middle of my equation when I'm having to add these as like terms and then solve. And that's really not helpful. This is certainly not seeming like a good route to go. So I'm going to backtrack and I'm going to say, you know what? Maybe there's a better way to do this. So now we're back to the beginning. Turns out you might want to be a little bit selective about your variables. I'm looking at this and I'm going to go, you know what? This y is by itself. It doesn't have any coefficient. That one's going to be really easy to solve for. Whereas a minute ago, the -7 on this y, I'm going to have to divide that off in a minute if I want to solve for y. And I'm going to divide it into that -3 and that 21, which means in a minute, this -3 and this -7 are going to become that fraction we just saw. That's not going to be a clean equation I want to work with. And it'd be the same thing if I wanted to solve for x. If I wanted to solve for x, I would have to divide off the -3 into every other value. And I'd still end up with this ugly fraction with my y variable. So the point here is, when you're going to solve for x or y, pick the easy, clean variable to solve for. Make your life easy. Pick something that when you rewrite it, doesn't give you ugly fractions, okay? So I would look at this and go, oh, that's really simple. Minus off the 2x to the other side, and very, very easily and very clean, I have y equals 9 minus 2x. Now let's clean all of this off the original equation. And we can see, if I wanted to go plug this value in for the y, it'd be really simple. Negative 3x minus 7. And this also is introducing a new type of substitution where you've got a multiple next to it. But notice we took the y that was multiplying with negative 7 and we replaced it with what we had over here, the 9 minus 2x. It was very, very easy to solve the first equation and plug that in. So let's make sure we do that. All right, let's practice that piece real quick. Here's three systems of equations, three sets of equations. Why don't you take a minute, and if you were going to be solving each of these using substitution, what would you do? What would you pick to solve for? There's definitely some easier variables to solve for here and some more kind of complicated, or they're going to create fractional values, kind of ugly ways you could do it. So take a minute and pick what you would do. Go. All right, let's dive in and look. First one, hopefully we're noticing that this y would be super easy to solve for because all you've got to do is divide off the 2. In fact, you can probably look at it and see 2 times what equals 12, 2 times 6. So really, it doesn't even require the math work. We can just see y equals 6. And notice, not only was that an easy one to solve for, there's not even an x. So I'm already halfway home to finishing my equation. I can just plug the 6 in for y, okay? We'll come back to that in a minute. Look at number 2, set number 2. They both have an equation with an x by itself. There's no coefficient on the x, which makes it really easy to solve it for substitution. In fact, this is kind of, this is like the perfect version of when you use substitution in a system of equations. When you have something really simple like that, or even on problem number 1 there, that's also really simple. That's when you want to use substitution. Okay, it'd be as easy as add over that 9y to the other side, and you've got an equation to solve for x. And notice, it doesn't matter x or y. You're just trying to find a quick, easy way to rewrite the equation that doesn't give you ugly fractions. If you want to graph, great. Fractions aren't an issue. That's just your slope. But if you're going to use substitution, we want to keep whole numbers, make life easy. Number 3. Did you scratch your head on number 3? I kind of threw a curveball at you with this set because there isn't any clean way to use substitution. If I wanted to solve for y, I would end up having to divide off the 2, and I would have to divide every term by 2, and I'm going to get a fractional value. Doesn't matter if I went the other direction and wanted to solve for the x in the end and get x by itself, I'd have to eventually divide off that 3 into each other term. And again, I'm just going to end up with that fractional value for x. So there's really nothing to be done there. Same exact thing on the bottom. This 8 on the x and this 3 on the y, they are not factors, so you can't divide them into each other cleanly. They're not multiples of each other or factors, so that third set, I would not ever use substitution. Okay. You could go with graphing on this third problem, or you could go with the third type of way you can solve. It's called elimination, that we're going to start learning next class. But I wouldn't use substitution on that third one. It's just not going to be helpful for you. You're looking for a simple, easy way to rewrite an equation so it's solved for x or it's solved for y. Those are the ideal substitution type of problems. All right, let's go back to that. All right, let's look at this guy here. If we're going to use substitution to solve this system, the first thing I notice is that neither of them are solved for x or y. They're both in standard form. So to use substitution, I'm going to have to rewrite one of these guys. Next, I'm going to look at what the easy one is to work on. Now if I notice here on the second equation, a 3 and a 2 are not a multiple of each other, so that's not going to come out clean. If I ended up trying to solve for y and divide off that 3, I'm going to get an ugly fractional value for x in a minute. If I get it solved for y, it's going to end up on the other side being a 2/3 x when I move it over. That is not helpful. I don't want to substitute using ugly values like that, so I want to stay away from that. So I look at the left side equation, and the obvious go-to is the y. It doesn't have anything I have to worry about as a coefficient, so I'm going to solve for that guy, and I'm going to flip the sign. So I'll add that 4x, move it over. And now I'll just flip those signs. Flip the sign of each of the terms, and it's still a valid equation. And now I've got something solved for y. So I can go to my other equation, find y, and replace it with this -7 minus 4x, and get rid of the y in that equation. Okay, so I'll go over here, rewrite the equation except for the y, and I'm just going to plug in. I found that the y equals -7 minus 4x, so I'm going to plug that in. The reason why I replaced the y with that is I've now got the variable x and only x. So now I've got an equation I can solve. I just shrunk down the equation from 2 variables to 1 using that substitution. Now, notice we also just created a distributing problem, which you guys know how to solve, but I just wanted to point that out because I'm such a nice guy. The 3 is now distributing to everything in here because the y was replaced by the -7 minus 4x. So it's 2 terms. It's more there than we just had with that single variable y. So it now becomes a distributing problem. -21 minus 12x. And you just solve like you always do. Okay? But again, you really got to have your solving skills together, or else you're gonna get into trouble here. Make sure you know how to do that. Okay, down at the end here, I'm just solving my 2-step. And 14 into 42, I believe, is 3 times with a single negative. And there we go. Okay, now at this point, what should you do? Hopefully you're telling me go back and plug in. Now, you can plug into A, the first equation, plug the x in there and find y. Or B, the equation you just used, you can plug in the x there to find y. Or you can even, option C, plug into the rewritten equation that you just solved for y. And this one is the easiest of the 3. That's going to be the least amount of work to solve, but all 3 of these equations are the same system. They're all going to give you the same solution, so pick whichever one looks easiest to you. So I'll pick this one, y equals -7 minus 4x. I'm going to plug in that x value we just found was -3, so I'll substitute that in. There we go, and just finish solving. -4 times -3 is 12. -7 plus 12 equals 5. There you go. So the y equals 5. And now I've got x -3, y equals 5. I'll put them together. And there's my final solution to this system. Okay, so the main point here with this problem is just to notice if you end up substituting and there's a coefficient there, it just creates a distributing problem, which you already know how to do. Distribute and then continue solving now that you only have one variable. All right, here's your guys' homework. Number 1, get one of the equations solved for x or y, and then number 2, solve the system using substitution. I will walk through and give you some pointers to help you out with this homework. So keep the video rolling here for a sec, and let's just talk about a few things and notice before you start. On problem 1, if we looked at the second equation, there's nothing really easy or obvious here in terms of substitution. If I'm going to divide one of those, the 7 into the 3 or the 3 into 7, it's not going to come out clean. But there is a really easy, obvious go-to with equation 1. That negative x, I'm really close to getting that equation solved for x, so go for that. That would be where you want to start. Number 2, hopefully you notice you don't even have to bother with plugging in to solve. You're already halfway home. It's a special case equation they gave you, y equals 9, so you can just go ahead and plug that in and solve for x, and you're done. Okay, those are the shortcuts, the easy ones. Be happy when you see those. Number 3, again, we've got a couple of routes. The 2 and the 4, you could solve for y, and if you do solve for y, you'll end up dividing off that negative 2, which will go into the 4 for a whole number on the x, and so you could solve for y on that one, but why would you? Because you've got another even easier choice with that negative x. Just solve for that negative x on the second equation, and that's an easy thing to plug in. Okay. Once you do that, remember on the first problem, you're going to plug in once you solve for x here. You'll end up with x equals on the first equation in a minute, and then you'll take that and plug it in. You're going to have a distributing problem after you do that, so just make sure you take care of that. And the second one, same thing. That second, or problem number 3. After you solve for x here, you're going to have x equals with everything on the right. Then you'll take that and plug it in, and then you'll end up having 4 times everything x equals. You've got another distributing problem you can solve. All right. Problem number 4, which point is a solution? We've walked through that multiple times. You've got 3 choices, A, B, C, 3 different points, and then you've got a system of equations over here on the right. So which of those 3 points is the correct solution to that system? Remember, to find that out, you've got to plug in, and it's got to make sure to match for both. All right, good luck. Talk to you later.